All right, so we're going to keep going with our transformations. For today, we're going to work with dilations. Dilations aren't crazy difficult thing, but do use fractions, so that can sometimes get a little tricky. As I mentioned before, you hear the word eye doctors. You go to the eye doctor, your pupils dilated. They put some drops in them, make them real big. For math, it works a little bit differently. We can get bigger or smaller. Either. So to dilate a figure, what you're doing is you're multiplying the x and y values of the ordered pair or ordered pairs by the scale factor. So the scale factor tells you what's happening to that shape. And all we're doing is we are multiplying. If the scale factor is greater than 1, it will enlarge the figure. It'll make it bigger. Usually, when they're greater than 1, sometimes, like rarely, you'll see just like an improper fraction. Okay, but usually it'll be whole numbers. If a scale factor is less than 1, then it will reduce the figure. It'll make it smaller. Less than 1 doesn't mean a negative number, though. It means something between 0 and 1. Usually that'll be a fraction. I would say probably at least 95% of the time, you'll either see whole numbers or fractions. Maybe 5% you will see decimals. Decimals are a little trickier, I think, but the fractions and whole numbers won't be so bad. Just multiplying with this part. All right, so you got this sample here without the red on your sheet. Go ahead and fill in the ordered pairs on the pre-image. So for A, we got -2, +1. Point B is +2, +1. Point C is 2, -1. And point D is -2, -1. All right, so the scale factor. In this case, this example here, the scale factor is 2. So what we do is we multiply each of those numbers by 2. So for A prime, I just multiply the y value. 2 times 2 is -4. 1 times 2 is 2. That's a -4, 2. Yeah, the board didn't cooperate. For B prime, same idea. 2 times 2 is 4. 1 times 2 is 2. Anytime with these, if the number starts off as negative, it's going to be negative after it's dilated. If it starts off as positive, it's going to be positive after it was dilated. So for C prime, I got 2 times 2, that's a +4. And -1 times 2, that's a -2. So that's +4, -2 there. And then for D prime, we get a -4, -2. That's not bad at all, is it? A second, it gets a little trickier, but for whole numbers, not that bad. Multiply each part of the ordered pair. Now, the other thing that gets multiplied, if you look at my two shapes here, my pre-image is the smaller one. If I go with the side lengths, I got 4 and I got 2. For the bigger one, y'all, what's 4 times 2? 8. And if you look, we got 1, 2, 3, 4, 5, 6, 7, 8 as the side length. Same over here, 2 times 2. I got 4 as my side length. So the side lengths get multiplied, like the lengths, basically every part of it's getting multiplied. If I found the whole perimeter on my smaller shape, whoops, I wrote that the wrong way, my fault. I got 4 plus 2 plus 4 plus 2. That's 12 is the perimeter here. Y'all, what's 12 times 2? 24. If I added up my big one, 8 and 4, 8 and 4, that's going to be 24. Okay? So that's how a scale factor works. It's just multiplying. I'm not worried about the algebraic rule. It's just whatever the scale factor is in front of x and y. So this would be like 2x and 2y. Not that big a deal. All right, so this got a fraction. If it's got a fraction, it is getting smaller. And that one is getting smaller. You can see the black triangle and the red triangle is the smaller one. So write down the order pairs for the pre-image. We got 3, 3, 3, 9, and 9, 3. All right, so when we got a fraction, there are 2 ways you can do a fraction. You can either make the number you have to start with a fraction. So if I got 3, I go 3 over 1, and I'm going to multiply it by 2/3. Everybody see how it looks? Whatever the whole number is, you multiply it by a fraction. Fraction straight across the top, and you go straight across the bottom. And then you'll probably have to simplify, because it'll usually be a whole number. So what's 6 divided by 3? 2. So what that means, since they're both 3s, my ordered pair here would be 2, 2. Any of my other 3s also are going to be 2s. So that's one way you can do them. Make a fraction with the whole number, straight across top, straight across bottom, simplify. Other way you can do it. Start with whatever the number is from the ordered pair, divide by the denominator. So my denominator was 3. So what's 9 divided by 3? 3. And then multiply by the numerator. So 3 times 2, 6. That means I got 6's right there. If I'm working it out, that's the way I would do it. A lot of times the fraction will just be like something like 1/2 or 1/4. So that makes it a little easier. You just divide by the denominator, and you don't really need to even multiply by the 1. So, but both ways works. Both ways would get you the correct numbers correctly. All right, these 3 aren't on your sheet. You got 3 similar ones on your sheet. We're going to do the 3 on your sheet in a second. This time, I'm trying to find the scale factor. If I am trying to find the scale factor, what you do is you take the image and you divide by the pre-image. So somewhere on your sheet, write that down. Image over pre-image. So remember, the image is the one with the prime marks. Image has prime marks. Pre-image has nothing. So if I look at this one on the left, the prime marks are on the smaller shape. That means it's getting smaller. That means we're going to have a fraction. So we need to take numbers from the image and put it over the pre-image. When you got rectangles like this, you just want to look at one of the x values, okay? So I'm going to use z, since it's right here on the right. Z prime is at 2. Everybody see that? Right at 2. So we're going to put 2 for our image. Z from the pre-image is at 6. So I got 2 over 6. If the number from the pre-image is bigger, it's going to be a fraction. And we got to simplify it. So what goes into both those? 2. So we divide each of those by 2. Our scale factor there will be 1/3. With ordered pairs, we pick an x value or a y value, and we do the same thing. I would try to avoid negative numbers. That just messes some of y'all up sometimes. If you can't avoid them, that's fine. I'll show you with negatives just for that reason. I'll use those 2 values. You just have to pick an x or a y, and it has to be the same for each one. It's x and an x or a y and a y, and it has to be corresponding ordered pairs. So like n and n prime. And we take the image and we put it over the pre-image number. Okay? When you have negatives, what's a negative divided by a negative? Positive. Negatives divided by negatives are positive. And then you just do the math. 6 divided by 2, 3. Scale factor is always going to be positive. Whether it's a fraction, whole number, or something else, it's going to be positive for the scale factor. The ordered pairs might have negative numbers when we get those, but the scale factor will be a whole number. So same idea here. My primes are the bigger one, so it's getting bigger. I take my image, A prime is at -6. A was at -3. So what's 6 divided by 3? 2. That's it. All right, so that's finding scale factor. When you find scale factor, you're dividing the image by the pre-image. Where'd it go? Y'all try the 3 on your sheet. Remember, if it's getting smaller, you'll have a fraction. It's getting bigger in most cases. Number 7 is a little tricky. You won't get a whole number there, even though it's getting bigger. You can leave it as an improper fraction, though. All right, who's got number 5? Oh, this one's getting smaller. You would have a fraction when it gets smaller. Eliana? We should try to simplify that, but yeah. So when we simplify that, that would simplify to 1/2. Okay? I'm going to use, let's use B. B's right there on a line. It's on the y-axis, right? So for B, my pre-image, it's at 8. So that's my bottom number. Pre-image on the bottom. My image is at 4. So I would have 4 over 8. 4 goes into both of those numbers, so we can simplify it. That simplifies to 1/2. If it's getting smaller, you need to have a fraction. So Nevaeh, you had it flipped. Or you just messed up when you looked at the division. Like 4 divided by 8 is different than 8 divided by 4. Number 6. Nevaeh. All right, what you want to do, pick an X or a Y value from one of the ordered pairs. Yo, we got positive numbers with R. Use the Y values. They're smaller. So we got a 3 and a 4 right there. It's the image over the pre-image. So it's 3 over 4. That can't be simplified. So it's 3/4. If I used the X values, I would have 6 over 8. I would have to simplify those, which simplifies still to 3/4. After Brian. Number 7 here. Who's got number 7? This one would be an improper fraction. Or a mixed number if you made it that way, but leaving it as an improper fraction is fine. All right, so we got 10 over 4. You use the t's, right? T and t prime. So our image was at 10, pre-image was at 4. If you put 10 over 4, though, that simplifies by 2's. So we got 5 over 2 if we keep it improper. Otherwise, it'd be 2.5 if we change it to a mixed number. Okay? Any questions on those? How did we get to 10? We use the x value. So where the point was at, just go straight down to the x-axis. You could also use y values, but in the case of the t, the y value isn't a whole number. You can use any point you want. So if we used S I would have used 5 to start with, and then 2. So it would have been 5 over 2, and we wouldn't have to simplify. Or I could have used the y values and done 10 over 4 for the s's with the y values. Okay? You can use any of the points on a shape. You can use either x or y, but you want to do the image over the pre-image, and it has to match up the same each time. So if I use s, I got to use s prime. Okay? If I use x the first time, I got to use x the second time. All right, so let's look at this one. I got a line segment here, AB. It is dilated or enlarged, it says, even by a scale factor of 4. Need the coordinates of A prime, so go ahead and find A. All right, who can give me the coordinates of A prime? Cam. Not over. 12, 8. Scale factors 4, right? All you do is you multiply the x value and the y value by 4. So 3 times 4 gave us 12. 2 times 4 gives us 8. When they give you the scale factor to get the coordinates, all you are doing is multiplying. You multiply x value by the scale factor, you multiply the y value by the scale factor. All right, so this time, same idea. We got dilation. So we need the coordinates for C prime. Leah, what you got? 3 2 is correct. When you have a scale factor of a fraction, you are doing the same thing. You can either multiply the 1/4 times each of those numbers times the 12 and then times the 8. If you do it that way, you got 12 over 1 times 1/4. That equals 12 over 4, which equals 3. 12 divided by 4 is 3. Your other way to look at this, or the other way you could do it, is you divide by the denominator and multiply by the numerator. So 8 divided by 4 is 2 times 1, still gives you 2. I said either way, either process works. Okay? Any questions?